Hello student, good morning. Today I am continuing from the last class. Now I am going to discuss molecular orbital theory. In short, it is called M.O.T. Molecular orbital theory. Molecular orbital theory was developed by F. Hund and R.S. Mulliken in 1932. The salient feature of this theory are: first, the electrons in a molecule are present in the various molecular orbitals as electrons of atoms are present in the various atomic orbitals. This is the first feature. Again I am telling you, the electrons in a molecules are present in the various molecular orbital as the electrons of atoms are present in the various atomic orbitals. Okay, same type of here in the place of atomic orbital you are telling molecular orbital. Situation is same. Second, the atomic orbitals of comparable energies and proper symmetry combine to form molecular orbitals. Here you have to consider two things: comparable energies. Atomic orbitals of comparable energies means almost same, and proper symmetry means structure should be or direction should be in the same, structure should be the same, combine to form molecular orbitals. This is the second. Again I am telling you, the atomic orbitals of comparable energies and proper symmetry combine to form molecular orbitals. Means molecular orbitals forms from atomic orbitals. Third, while an electron in an atomic orbital is influenced by one nucleus, in molecular orbital it is influenced by two or more nuclei depending upon the number of atoms in the molecule. If in a molecule 2 atoms are there, then 2 nuclei. If 3 are there, then 3 nuclei. Thus an atomic orbital in a monocentric while a molecular orbital is polycentric. Okay, here again you understand that what I have told you, third point, while an electron in an atomic orbital is influenced by one nucleus, in a molecular orbital it is influenced by two or more nuclei depending upon the number of atoms in the molecule. Thus an atomic orbital is monocentric while a molecular orbital is polycentric, because in a molecule more than one atoms are there. Fourth point, the number of molecular orbital formed is equal to the number of combining atomic orbitals. Both numbers are same. The number of molecular orbital formed is equal to the number of combining atomic orbitals. When two atomic orbital combines, two molecular orbitals are formed. This is important. One is known as bonding molecular orbital, while the other is called anti-bonding molecular orbital. Fifth point, the bonding molecular orbital has a lower energy and hence greater stability than the corresponding anti-bonding molecular orbital. Again, all points are important only. Again, fifth point I am telling you, the bonding molecular orbital has a lower energy and hence greater stability than the corresponding anti-bonding molecular orbital. Bonding orbitals are stable and anti-bonding orbitals are weak. Okay, this you have to understand. Next point, 6. Just as the electron probability distribution around a nucleus in an atom is given by an atomic orbital, the electron probability distribution around a group of nuclei in a molecule is given by a molecular orbital. Okay, listen again. Just as the electron probability distribution around a nucleus in an atom is given by an atomic orbital, the electron probability distribution around a group of nuclei in a molecule is given by a molecular orbital. Around the nucleus, electrons will be there in any atom. Like that way, here around the group of nucleus, because in molecule maybe 2-3 atom, then around the group of nucleus electron will be distributed. And the last point, that is the 7 point, the molecular orbitals like atomic orbitals are filled in accordance with the above principle, same principle, obeying the Pauli's exclusion principle and the Hund's rule. Here also in this theory, again above principle, Pauli's principle, Pauli's exclusion principle and Hund's rule is applied. This I have told about the feature of molecular orbital theory. It is a 7 point I have discussed. Then these 7 points are applied in this molecular orbital theory, and it is just conceptual. It is not very difficult. Only you have to understand the some concept, then it will be also easy. Okay. Now next things I am going to discuss, formation of molecular orbitals. How molecular orbitals are forming, that I am going to discuss. That is also called linear combination of atomic orbitals. Linear combination of atomic orbitals. Shortcut LCAO. Linear combination of atomic orbitals. LCAO. Now just understand, this is not difficult. Just listen carefully. According to wave mechanics, already I have discussed, according to wave mechanics, the atomic orbitals can be expressed by wave function psi. Wave function psi, which represent the amplitude of electron wave. Amplitude of electron wave. Psi represent amplitude of electron wave. These are obtained from the solution of Schrödinger wave equation. What is its value? These are obtained from the solution by solving solution of Schrödinger wave equation. However, since it cannot be solved for any system containing more than one electron, it is very difficult. If you will consider any system, means any atom or any molecules when a number of electron is more than 1. This is important things here. It is very difficult. Since it cannot be solved for any system containing more than 1 electron, molecular orbital which are 1 electron wave function, molecular orbitals which are 1 electron wave functions for molecules are difficult to obtain directly from the solution of Schrödinger wave equation. It is very difficult. Then what are the substitute? Then an approximate method known as linear combination of atomic orbitals has been adopted. Hence, it is very difficult for a molecule to solve the Schrödinger wave equation. Okay, in a molecule it is very difficult. Molecular orbitals which are 1 electron wave function, 1 electron wave function for molecules are difficult to obtain directly from the solution of Schrödinger wave equation. It is not possible. To overcome this problem, an approximate method known as linear combination of atomic orbitals has been adopted. Now I am going to discuss by taking examples of homonuclear diatomic hydrogen molecule. Diatomic hydrogen molecules means H2, and this will take example. How it is formed H2, just to understand. Actually, already you know HH, then it will form H2, but now that's in a simple way you are telling. But what happens exactly inside, that you have to understand. Then now consider the hydrogen molecule consisting of 2 atoms A and B. Each hydrogen atom in the ground state has 1 electron in 1s orbital. Okay, 1s and other also 1s. The atomic orbitals of these atoms may be represented by the wave function psi A and psi B. You can represent like this also. The atomic orbitals of these atoms, may be represented by the wave function psi A. I told you wave function, just to recall, already I discussed in details. Psi means it will tell all the things, all information you will get by psi, the word psi. Just like I already told you, Trishul sign, like that way. Then it tells all information you will get by this symbol. Okay. Then this, suppose for atom A it is psi A and for atom B psi B. Means psi A will tell information about the A atom and psi B will tell information about the psi B. Okay. Then now understand, here actually main thing is that in molecular orbital, what I am telling you, that 2 atoms will be there, A and B. Hydrogen atom A, hydrogen atom B means psi A and psi B. Here what will happen? 2 situations are there. When electrons will be between the two nuclei, then what will happen? Suppose there is no electrons in between the nuclei, nucleus A and nucleus B, in between no electrons are there. First you consider. Then repulsion will be there. Nucleus A and nucleus B, there will be repulsion, too much repulsion, and it will be unstable. But electron will be in between the two, then that repulsion will decrease, and this electron will bind to nucleus. This electron will bind to nucleus. Repulsion will be very, very less. That is the one case. Means when repulsion will be less, then molecule will be stable. H2 molecule will be stable. Okay, that is called bonding. This is called actually bonding. And now another situation that when electrons are far from nucleus, then automatically what I told, that repulsion will be there between the nucleus, then bond can't be formed, molecules will be very unstable. Then when electrons will be far from the nucleus, that time it will be called anti-bonding. And when electrons are between the nucleus, then it is called bonding. That is the meaning of bonding and anti-bonding. Then in bonding, both will combine. Okay, both atom will combine, plus sign will come. And when they are far, then that time minus will come. Okay, then psi A plus psi B, that is called bonding. And psi A minus psi B, that is called anti-bonding. This is the main things I have briefed you. Now just you listen about all the things that mathematically the formation of molecular orbital may be described by the linear combination of atomic orbitals that can take place by addition and by subtraction of wave function of individual atomic orbitals. How? Just I told you already that psi molecular M.O, down you can write psi, down you write M.O, means molecular orbital. Then psi M.O is equal to psi A plus psi B. Psi A plus psi B means combination of atomic orbitals of A and B. Therefore, the two molecular orbitals for the S orbital we are using, for bonding we are using the sigma symbol we are using for the bonding, and for the anti-bonding sigma star symbol is sigma star. You write sigma and the top you put one star, that is called sigma star, that is called anti-bonding. This is the indication for bonding and anti-bonding orbitals. Then now you can understand, therefore the two molecular orbitals sigma and anti-bonding sigma are formed. Bonding and anti-bonding orbitals are formed. Then sigma is equal to sigma A plus sigma B, that is called bonding orbitals. And sigma star means anti-bonding is equal to sigma A minus sigma B, because they are far from the nucleus. The molecular orbital sigma formed by the addition of atomic orbitals is called the bonding molecular orbital. Bonding molecular orbital, 1 marks question. What is the bonding molecular orbital? While the molecular orbital means sigma star formed by the subtraction of atomic orbitals is called anti-bonding molecular orbital. sigma star, that is called anti-bonding molecular orbital due to the subtraction minus, okay, sigma anti-bonding, sigma that is called sigma A minus sigma B, that is called anti-bonding molecular orbital. Again, one more important point where I want to tell you, in diagram you can understand well. Actually, these two atomic orbitals have energy. Then what will happen? That when they will add, when sigma when psi A and psi B, when both orbitals, atomic orbitals will add, and they will make molecular orbital. From the atomic orbitals, molecular orbitals formed. This you keep in mind. Just like formation of molecule, same way here. Then when they will add, then that time their energy will be less than these two orbitals. These two orbitals, when they will add, because they are adding, they are between the nucleus, the nucleus repulsion will be less. Okay, repulsive force will be less, means energy will be also less. Repulsive force will be less means energy will be less. Hence now in case of bonding orbital, their energy will be less than this parent atomic orbital. You can tell parent atomic orbital, original atomic orbital. Then after combination, their energy will be, both will have less energy. Hence you can write one energy level less, down, it will be in the middle atomic A and B atomic orbitals. If you are writing, then from that atomic orbital, after the addition, means forming a molecular orbital, their energy will be less than this. And second, when they will be far from the nucleus, means anti-bonding, then that time energy will be more, because they will go up, only electrons will be there. Then among the electrons, repulsion will be there, repulsive force will be there. Or also you can tell nucleus repulsion will be more. That's why energy will be more. Then energy will be more. Then in comparison to the parents atomic orbitals, energy will go, molecular anti-bonding, they will have more energy. Hence energy level will be high. Hence if you write by figure diagram, then it will be in the middle, original means parent will be in the middle, and bonding will go down, and up will be anti-bonding. This is, I have told you, I will send this diagram, you can understand. Okay, then always keep in mind, after mixing atomic orbital, molecular orbital is formed. Correct? Atomic orbital A, atomic orbital B, after mixing they will make one molecular orbital. Okay, this you keep in mind. Now I am going ahead. What I have discussed again in details, now I am telling you. Qualitatively, the formation of molecular orbital can be understood in terms of the constructive or destructive interference of electron wave of the combining atoms. Electron, I told you, electron is also called wave. Dual character, I have told you, dual character means as a matter and as a wave. Then in higher classes it is considered as a wave. Then there will be two type of, you can say, constructive or destructive interference. Constructive or destructive interference of the electron wave of the combining atoms. In the formation of bonding molecular orbitals, the two electron wave of the bonding atoms reinforce each other due to constructive interference, while in the formation of anti-bonding molecular orbitals, the electron wave cancel each other due to destructive interference. As a result, the electron density in bonding molecular orbital is located between the nuclei of the bonded atoms, because of which the repulsion between the nuclei is very less, while in case of an anti-bonding molecular orbitals, most of the electron density is located away, I am telling you, far away from the space between the nuclei. In fact, there is a nodal plane. Nodal plane means where there is a no electron. Electron density is 0, no electron. Okay, that is called nodal plane. In there, no electron density will be 0. Then I was telling you, in fact, there is a nodal plane on which the electron density is 0 between the nuclei, and hence the repulsion between the nuclei is high, because electron density is no electrons are there, hence repulsion between the nuclei is high. Electrons placed in a bonding molecular orbitals tends to hold the nuclei together and stabilize. If electron will be in between the two nuclei, then they will hold the both nuclei and stabilize a molecule, because when both nuclei are coming, it means molecule is forming, then you can tell that it will stabilize a molecule. Therefore, a bonding molecular orbitals always possesses lower energy than either of the atomic orbitals, means parent orbitals, that have combined to form it. In contrast, when just against these things, in contrast, opposite to this, the electrons placed in the anti-bonding molecular orbitals destabilizes the molecule. That's why name has given anti-bonding. Anti-bonding molecular orbitals destabilize the molecule. This is because the mutual repulsion of the electrons in this orbital is more than the attraction between the electrons and nuclei. See, here you have to understand. Then mutual repulsion of the electrons in this orbital, in the case of anti-bonding I am talking about, in this case, mutual repulsion of the electrons in this orbital is more than the attraction between the electrons and the nuclei. If electrons are in the middle of nucleus, then they will attract to each other, nucleus and electron, attractive force. But whatever is this attractive force, then in anti-bonding, what is the repulsive force? That is more. Repulsive force is more than this attractive force. Okay, that's why they will destabilize. They will destabilize the molecules. Means anti-bonding will destabilize. Destructive interference, that is called. This is the important things. The mutual repulsion of the electrons in this orbital is more than the attraction between the electron and the nuclei, which cause a net increase in energy. Okay. It may be also noted that the energy of the anti-bonding orbital is raised above the energy of the parent atomic orbitals. Already I told you, anti-bonding, they have more energy, they will go up. Okay, that is parent atomic orbital means original. Energy of the anti-bonding orbital is raised above the energy of the parent atomic orbitals that have combined, and the energy of the bonding orbital has been lowered than the parent orbitals. But again, one more thing you have to understand. The total energy of the two molecular orbitals, means bonding and anti-bonding, if you will consider both, you will add energy of anti-bonding plus energy of bonding, then it will become equal to the energy of parent atomic orbitals. This you have to understand. The total energy of two molecular orbitals, however, remains the same as that of the two original atomic orbitals. Okay. Then today I am stopping only here, and next class again I will continue. Thank you.